Hey everybody. So we're looking at 13.2 today, getting into sine and cosine ratios. All right. But before we get into this, real quick, I want you guys to try out a warm up using the tangent ratio we learned in the last lesson to find the missing side of this triangle. All right. I already have, the ratio written out here. Tangent of, the angle equals opposite side over adjacent side. So go ahead and plug in those side lengths to the ratio and solve for x, and then we'll get going. Okay, so on this problem, first thing, the reason why we're using tangent, I always like to point that out, is, this is the angle that we're going to be using. And I noticed that we have the side length opposite our angle, and we have the leg adjacent to our angle. Just remember, this side length right here is always the hypotenuse. It's across from that 90-degree angle. All right, so that's why opposite and adjacent tells me we're using tangent, which is the only one we know right now, but eventually we'll have to decide which one we need to use. Okay, so anyway, let's go ahead and write out. So tangent of our angle, which is 25 degrees, equals opposite over adjacent. Opposite is 9, and the adjacent side is x. Okay, be careful. Check your ratio. Make sure you didn't do x over 9 and got those mixed up. Okay, so when we go to solve these equations, remember the first step is always the same, and that is multiplying by whatever is in the denominator, whether it's a variable or if it's a number. Okay, on this one, it looks like we have an x down on the bottom, so we're going to multiply both sides by x. Okay, I like to start on the right, cancel those out. I got 9 left over. On the left here, I have x times tangent 25. I'm just going to bring it down. I'm going to take away the parentheses because I like to write it this way. Okay, so there is my, next step. From here, now I can solve for x. It's being multiplied by tangent 25, which remember, that is just a number. If we were to type that into a calculator right now, we would just get some decimal. Okay, so it's being multiplied by a number. So to get rid of it, we're going to divide. Okay, and we have to do it to both sides. Okay, so yeah, these are canceling and I'm getting x by itself. Over on the right, 9 divided by tangent 25. This is what we need to type into our calculator. All right, so again, I recommend getting a physical calculator, from the library, from Amazon, whatever. But if not, you can use the GeoGebra, the scientific calculator. So let's go and try it out. So we have 9 divided by tangent 25. So 9 divided by tangent 25. Oops, that put in way more. Okay, looks like we're getting 9.30. So that 3 is not rounding up to a 4, it's just staying a 3. So 19.3 is our answer. Okay, and there it is. Okay, always a good idea. Does that make sense? The short leg is 9. Does it make sense for the long leg to be 19.3? Yeah, that sounds about right. Okay, so this right here, if you can do this process, this lesson today is not going to be any more difficult. We're just going to be using 2 new trig ratios that are going to have a different ratio of sides, but the actual solving is going to be exactly the same. Okay, so let's get into it. So first things first, go ahead and get the title at the top of your paper, get these 2 new trig ratios, sine and cosine, and then draw yourself this little triangle because I'm going to kind of use it as a, an example when I'm looking at these ratios. Okay, go ahead and get it. All right, so sine and cosine, I guess first thing, SIN, we use that as the shorthand for sine. Okay, people always say sin. No, it's sine. Same thing with this one. COS we use for shorthand for cosine. Okay, so here's the ratio. Sine equals opposite side over the hypotenuse. Cosine equals adjacent over hypotenuse. Okay, and that's really the only difference between these and the one we just used, which was tangent. All right, so here's a little reminder. Say on this triangle, say we had, A, B, C, and say a problem asked us to find sine of angle A. Okay, well, we would, of course, go to angle A, and here's what we would realize. Sine is opposite over hypotenuse. Okay, the side length opposite our angle would be this side length, and the hypotenuse is always this longest side. And remember, it's always across from the 90-degree angle if you ever forget it. So the nice thing about these is we don't need to really guess about the hypotenuse. It's always in the same spot. Okay, but do remember the opposite side depends on what angle we're looking at. Another example, if we were looking at angle B, the side length opposite angle B would be this one, and then again the hypotenuse would be this. Okay, and it's the same idea with cosine. The cosine is adjacent over hypotenuse. All right, just remember when we have an angle, say we're looking for cosine of B here, cosine adjacent means the leg that is touching the angle that is not the hypotenuse. So adjacent would be this one, and then again the hypotenuse would be this. Okay, so that's going to be kind of the focus of today. First is just getting used to using these ratios, and then from there we can actually use them to find some missing side lengths. Okay. All right, so let's go ahead and do this one together. We're going to find sine of angle S and R, and then cosine of angle S and R. Go ahead and copy this, get the triangle, and we'll do this together. Okay, so let's start by finding a sine of angle S, and then we'll do sine of angle R. So starting with S, there's our angle S. All right, let's go ahead and just write this out. Sine of angle S equals, and just a quick reminder, sine is opposite over hypotenuse. Okay, so if we're looking at angle S, first thing is figuring out which side is opposite our angle, and it looks like it's going to be 63. So 63 goes up top. And then on the bottom goes the hypotenuse. Remember the hypotenuse, there's no guessing on this. It's always that long side. It's always across from that 90-degree angle. So 65 goes on the bottom. Okay, and again, if they had asked, sometimes they'll ask for a decimal on this, kind of like when we did our worksheet. They're not asking for that, so we're good. We're just practicing making the ratios. Okay, let's do the next one. Sine of R. Okay, so now we're looking at angle R, and again, sine opposite over hypotenuse. The side length opposite our angle is this one, 16. And the hypotenuse, just like before, is 65. Okay, so there's sine. What I want you guys to try is to do the cosine problems. Go ahead and do cosine of angle S, and then cosine of angle R. Just remember, cosine is adjacent over hypotenuse. Okay, so go ahead and start with angle S here, and go ahead and figure out the ratio of the adjacent side over the hypotenuse. Give it a try. Okay, so here's usually adjacent is the more difficult one to figure out. Here's a surefire way of doing it. If we're looking at angle S, here's what we know. We know this is the opposite side. We know this is the hypotenuse, so this must be adjacent. Okay, when in doubt, just eliminate the obvious ones, and then you're left with the adjacent leg. All right, so adjacent is 16, and then again, the hypotenuse never changes. It's always this side length, which is 65. Okay, moving over to cosine of angle R. Okay, again, if we want to eliminate the obvious, the opposite side, which we're not using on cosine, is 16. Okay, the hypotenuse is 65, and that means 63 is our adjacent side. And that's the surefire way of doing it. But just remember, adjacent leg is the one that's touching our angle. That's not the hypotenuse. Okay, but yeah, hypotenuse on the bottom, 65. Okay, so yeah, that's the big thing. If kids struggle with this lesson, it's because they don't know how to identify the three side lengths. So that's really the big thing here. If you still have any questions on this, please let me know, and I can maybe explain it a little more thoroughly. Okay, so now that we know how to do that, let's go ahead and find some missing side lengths of a triangle. Go ahead and copy this example. We'll find X and Y. Okay, so first thing, let's just start by finding angle X here. Okay, or sorry, side length X. All right, so here is the angle that we're using, 32. Here is the question. When we go to find this side length X, which of our trig ratios should we use? Okay, we don't get to just randomly pick them. We have to see which side lengths we're dealing with, and then we'll realize, oh, we're using tangent or sine or cosine. It just depends. Okay, so here's the thing. If we're finding this side length, our other side length we want to use that one that we actually know. Okay, so we're going to use this side and this side, all right, to find X. Okay, so here's the question. Which side lengths are we dealing with in regards to this angle? Well, we have the side length opposite our angle, and 18 is the hypotenuse, right? So opposite hypotenuse. I'm trying to think, okay, which one of our trig ratios uses opposite and hypotenuse? Well, it looks like sine uses opposite and hypotenuse. Okay, so that's why we must use sine to find this missing side length. Okay, so that is the first step, figuring out which trig ratio you're using. We figured out we're using sine of our angle, 32 degrees, equals opposite x over hypotenuse, 18. Okay, so I'm going to erase some of this stuff. All right, cool. So now we can go ahead and solve here. Remember, when this first step is always the same thing, we will always multiply by what's in the denominator. Looks like it's 18, both sides. Okay, so these are the quicker of the problems. These ones are nice because those cancel and we get x by itself immediately. Over on the left, this is what we need to type into our calculator, 18 times sine 32. So let's go ahead and do it. Okay, so I'm just going to delete this. So 18 times, I don't need the parentheses, sine 32. And it looks like I'm getting 9.53. So that means that 5 does not round up. It just stays 9.5. All right. So, sorry, what is this doing here? Sorry about that. So yeah, we're getting 19.5. Or why do I keep saying 19? 9.5. Okay, cool. So then that's it. I'm just going to go ahead and flip it around, 9.5. All right, and just real quick, my hypotenuse is 18. Does it make sense for the short side to be 9.5? Yeah, that's about right. Okay, but we're not done. We still need to do it for our other triangle. So let's go, or our other side length, excuse me. So let's find side length y. Okay, again, I'm going to use this same angle. All right, and I'm going to use, I'm finding y, and I also want to use a side length that we know. Okay, we know the hypotenuse. We also now know this side length, but I'm going to use the hypotenuse just because we didn't round it, and we'll get a more, I guess, accurate answer. Okay, so here's what we got. If I'm looking at y, I notice that it is the leg adjacent to our angle, and again, 18 is the hypotenuse. So adjacent and hypotenuse, I'm going back to my trig ratios and I'm thinking which one of these uses adjacent and hypotenuse? Cosine. Okay, so now we know we must use cosine to find this missing side length. So let's do it. So cosine of our angle equals the adjacent side over the hypotenuse. All right, take a look at these two things. Almost exactly the same. It just so happens the only difference is we're clicking a different button in our calculator. We're using cosine. Okay, but let's show our steps. We're going to multiply by that denominator, both sides. All right, looks like we're getting y equals 18 times cosine 32. Let's go ahead and type that into our calculator. Okay, so delete 18 times cosine 32 gives me 15.26. So that 6 is going to round this 2 up to a 3, so 15.3. Okay, and then let's flip it around. Okay, and again, real quick, let's check. If our hypotenuse, our longest side length is 18, does it make sense for the long leg to be 15.3? Yes, yeah, that makes sense. Okay, so yeah, nothing too different here. It's just making sure we're picking the right trig ratio and then getting our side lengths in the correct spots. Okay, so I'm gonna have you guys try one on your own and go ahead and find side length R and T on this problem. Obviously, you're gonna be using this angle. Okay, so I would start with side length R. First, decide which of the trig ratios do you need to use. All right, you have this side length, and you also are given this one. Those are the two you want to use to find R. Okay, so figure out, are you using sine? Are you using cosine? Are you potentially using tangent? Okay, figure it out. Okay, so here's what I noticed. If we're using this angle, R is adjacent to our angle, and 11 is the hypotenuse. So real quick reminder, adjacent hypotenuse, that is cosine. Okay, so I must use cosine to find R. So let's go ahead and do it. So cosine of our angle, 47 degrees, equals adjacent over hypotenuse. Adjacent is R over hypotenuse, 11. Okay, that's the big thing. If you can do this, it's hard to mess it up from here. We know we're going to be multiplying by that denominator no matter what. So it looks like they cancel and I get R on the right. On the left, it's just me typing this into the calculator, 11 times cosine 47. So let's see what we got. So 11 times cosine 47. Why does it do that? It like throws in a bunch of sevens sometimes. Okay, so it looks like we're getting 7.50. So that's just going to round to 7.5. Okay, and let's flip it around. Okay, real quick before we move on, does that make sense? Our hypotenuse, our longest side is 11. The short leg is 7.5. Yeah, that looks about right. Okay, so let's go ahead and do the next one here. So we're using the same angle, but now we're going to be finding side length T. Okay, so let's figure it out. I noticed that T is opposite our angle, and 11 again is the hypotenuse. So we're using opposite and hypotenuse. Which trig ratio deals with opposite and hypotenuse? Sine. Okay, so we're going to use sine to find this side length. All right, so let's write it out. Sine of 47 degrees equals opposite T over hypotenuse 11. Okay, you guys might notice in the last couple examples, our variable ended up in the numerator. That's not always going to happen. So just be careful. Don't always assume it's going to end up there. Okay, but yeah, multiplying by that denominator, we're getting T on the right, on the left, 11 times sine 47. Let's go ahead and do it. 11, did it again. 11 times sine 47. It looks like we're getting 8.04, so that's just going to round to 8.0. And there it is. Okay, just real quick, our long leg is 8, our short leg is 7.5, our hypotenuse is 11. Yep, that all makes sense. Okay, just, for example, say I did this one wrong and I got that T equaled 13. Does it make sense for this leg to be 13 when our hypotenuse is 11? No, the hypotenuse should always be the longest side. Okay, so we can find mistakes if we just kind of look at it. Okay, cool. So let's do one more of these together, and then I'll let you guys go off and do your thing. Okay, so go ahead and get this example, and we'll find P and Q on this. Okay, so first things first, here is the angle we're given. We might as well use it. All right, and let's go ahead and find P first. Okay, so here's the side length that we are finding, and here is the side length that we know. All right, so let's figure out what we have according to this angle. We have the side length opposite our angle, and P is the hypotenuse, right? Because it's across from the 90-degree angle. So I have opposite and I have hypotenuse. What should I be using on this? Opposite hypotenuse is, again, sine. All right, so now I know I'm using sine to find this missing side. So sine of our angle, 64 degrees, equals opposite 10 over hypotenuse P. Okay, so notice variables landing on the denominator of this one, that happens. Okay, but we know no matter what, we're always going to be multiplying by what's in that denominator, whether it's a number or a variable. That's the very first step we'll always do. Okay, so those p's cancel. I get 10 on the right. On the left, I'm going to rewrite this, p times sine 64. Okay, by the way, you might be tempted to not rewrite this and then do divided by in this step, but then things start to get, you kind of start to, I guess, jumble up everything. So, rewrite it and then do the division. Okay, so yeah, it's being multiplied by sine 64. Let's go ahead and divide by sine 64, both sides. All right, so they're gone. We got P by itself. Last thing, just type that into your calculator, 10 divided by sine 64. So 10 divided by sine 64 gives me 11.12, which means that one's going to stay a 1, so 11.1. All right, just real quick, that's our hypotenuse. Okay, it is longer than, the long leg. It should be, so it's looking good so far. Okay, let's go ahead and do for the next one. Okay, so now instead of finding P, we're going to be finding Q. All right, so yeah, sorry, let me make it red just so I can stay consistent. Okay, so let's use these values that we have. We're looking for Q. We already have this side length. We might as well use it. So let's see what we got. So we have the side length opposite our angle, and Q is adjacent to our angle. Okay, so opposite and adjacent. Which one of our trig ratios deals with opposite and adjacent? Well, it's neither one of these. It is going back to tangent. All right, so don't forget about tangent. It's still part of our potential trig ratios that we need to use. So yeah, tangent of opposite, or sorry, of our angle equals opposite over adjacent. All right, so here's something kind of interesting. I know that when I go to do all of these steps, the only thing that has changed between these two problems is the fact that instead of sine, we're using tangent. I know eventually I'm going to take 10 and I'm going to divide it by tangent 64. Okay, that's going to happen on this. And, if I were doing this maybe by myself, I would probably just jump to that and I would type that in my calculator. But since we're, doing some notes, let's go ahead and just show, we're going to multiply by the denominator, both sides. That cancels. I get 10 on the right. I get Q times tangent 64. And now I can go ahead and divide. Okay, but I just want to point out, you can start to kind of see patterns. And I guess, something worth pointing out. Actually, let's complete this and then I'll point out something that might help you. Okay, so these are gone and I get Q equals 10 divided by tangent 64. Okay, so let's type that in. All right, so 10 divided by tangent 64, 4.87, rounds that 8 up to a 9, so 4.9. Okay, and just double check, that's our short side, 4.9, that's all fallen into place, that looks good. Okay, but here's a little pattern I want you to start to kind of realize. Whenever our variable is in the denominator, we end up dividing our numbers, 10 divided by sine 64. That always happens when our denominator is in the, our variable is in the denominator, the bottom. Okay, when our variable is in the numerator, instead of dividing, we end up multiplying our numbers. Okay, and that actually always happens. Okay, I want to see these steps, but I want you to just kind of realize, okay, variable up top means I'm multiplying, variable on the bottom means I'm dividing. Okay, that's always going to happen. It's always a good thing to keep in mind. All right, guys, so yeah, that's our other two trig ratios. Our next lesson, we're going to get into finding missing angles using the trig ratios, which the good news about that, it's even easier than finding missing sides. Okay, but I'll see you then. Bye.